Hi, I'm Carmen ANDERT with the Math Department here at GRCC. Today we're going to talk about solving absolute value inequalities. First, I want to review just the basics about absolute values. The absolute value of a number x is denoted by the number x with a vertical line on each side. And the absolute value of x represents the distance on the number line between 0 and x. Let's look at an example to help visualize the idea of absolute values. Let's compare the absolute value of x to the number 5. On the number line, there are two numbers, 5 and negative 5, that are exactly 5 units away from 0 on the number line. So for these two numbers, the absolute value of x is equal to 5 because for these two numbers, the distance away from 0 is equal to 5. Now, for this set of numbers that's between negative 5 and 5, each of those numbers is less than 5 units away from 0 on the number line. So the distance between x and 0 for those numbers is less than 5. Lastly, the numbers to the right of 5 and to the left of negative 5 are both more than 5 units away from 0 on the number line. So the absolute value of x is greater than 5. Also, for the numbers less than negative 5, the absolute value of x, or the distance away from 0 on the number line, is greater than 5. This means that if x is 5 or negative 5, then the absolute value of x equals 5. If x is greater than negative 5 and x is less than negative 5, the absolute value of x is less than 5. And if x is less than negative 5 or x is greater than 5, then the absolute value of x is greater than 5. All right, now let's focus on solving absolute value inequalities. If k is a positive number, then the absolute value of x is less than k means that x is greater than negative k and x is less than k. And the absolute value of x greater than k means that x is less than negative k or x is greater than k. Similarly, we have the rules for the inclusive inequalities, that the absolute value of x is less than or equal to k means x is greater than or equal to negative k and x is less than or equal to k. And the absolute value of x is greater than or equal to k means that x is less than or equal to negative k or x is greater than or equal to k. For our first example, let's solve the inequality. The absolute value of a plus 6 divided by 5 is less than or equal to 4. Because the absolute value is less than or equal to 4, we know that a plus 6 divided by 5 is greater than or equal to negative 4, and a plus 6 divided by 5 is less than or equal to positive 4. Now I just need to solve these two inequalities. For the first one, I'll multiply both sides by 5. That gives us a plus 6 is greater than or equal to negative 20. And then I'll subtract 6. So a is greater than or equal to negative 26. For the second inequality, I'll multiply by 5. We get a plus 6 is less than or equal to 20, and then subtract 6 tells us that a is less than or equal to 14. Now I need to combine these two using interval notation. That tells me that a is between negative 26 and positive 14. And I can include the two endpoints. For our next example, we'll solve the inequality that says the absolute value of 2x minus 8 plus 3 is greater than 11. Because the absolute value is not yet by itself on the left side, I'm going to subtract 3 from both sides first. So the absolute value of 2x minus 8 is greater than 8. Now, because the absolute value is greater than 8, I know that 2x minus 8 is less than negative 8, or 2x minus 8 is greater than positive 8. Now I just solve each of these two inequalities. For the first one, adding 8 to both sides, we get 2x is less than 0. And then dividing by 2, x is less than 0. For the second inequality, when I add 8 to both sides, we get 2x is greater than 16. And then dividing by 2, x is greater than 8. Now, combining these into interval notation, x is less than 0 gives me the interval from negative infinity to 0. And x is greater than 8 gives me the interval from 8 to infinity. Because I have or between my two inequalities, I use the union symbol to join the two intervals. Now let's talk for a moment about unusual absolute value inequalities. So if k is a positive number, and I'm looking at the absolute value of x is less than negative k, or the absolute value of x is less than or equal to negative k, either one of those inequalities has no solution because the distance from 0 to x cannot be less than a negative number. On the other hand, if the absolute value of x is greater than negative k, or the absolute value of x is greater than or equal to negative k, then all real numbers are solutions because the distance between 0 and x on the number line is always greater than a negative number. Suppose I want to solve the inequality, the absolute value of 9x plus 9 is less than 7. First, we need to isolate the absolute value on one side. So I'm subtracting 9. The absolute value of 9x is less than negative 2. Now the absolute value of 9x, regardless of what number x is always greater than or equal to 0, so it cannot be less than negative 2. So this inequality has no solution. For our last example, let's solve the inequality. The absolute value of 2/3 m plus 3 plus 9 is greater than or equal to 2. Again, I need to get the absolute value alone on one side. So I'll subtract 9 from both sides. So the absolute value of 2/3 m plus 7 is greater than or equal to negative 7. Now we know that no matter what number m is, the absolute value on the left side of this inequality is 0 or bigger. So that's greater than or equal to negative 7 for all values of m. So your solution is all real numbers, or in interval notation, the interval from negative infinity to positive infinity. I hope this has helped you know how to solve absolute value inequalities. If you have any questions, ask your teacher or visit the GRCC Tutoring Lab.